All right, so in 7.1 we did substitution and graphing, okay? Notice that the directions tell you could do either one, so you get to choose here. Keep in mind that quiz-wise and test-wise, you'll be prompted to use certain ones. So like in the beginning, especially the quiz, it will tell you, use substitution to do this one, use graphing to do this one. It'll give you the graphing, like a coordinate grid. And then today we're going to talk about elimination. And then there's some that are just going to say solve, and you can choose which way you do it, okay? But these, we want to practice substitution or graphing. So for number 1, let's say you did substitution. Probably the easiest thing to do is to take the top and solve it for y. How many of you did that? Okay, good. So I would have gotten negative y equals 14 minus 6x, and y equals negative 14 plus 6x. And then take that and plug it into the y on the other equation. So 2x plus 3 times negative 14 plus 6x equals 18. 2x minus 42 plus 18x equals 18. 20x at the 42 here equals 60, and x equals 3. And then take that and plug it back in, and you can plug it back into either the original ones or the ones we already solved for y, which is probably easiest. Negative 14 plus 6 times 3, negative 14 plus 18, and y is 4. So 3, 4 was the solution to that system. Questions on that one? Okay, yep.
How do you take that with the graphing? I mean, like, how would you type?
You have to solve them each for y first, and then you type them in.
Oh. Okay.
So like I'd have to type it in like this for the top one, and then the second one I'd have to subtract the 2x and divide by 3. So in order to use your graphing calculator, you have to get it equals to y.
Oh,
yeah. Mm-hmm. All right, then 2, most of them. Some of them change the variable, but most of them you have to be y equals. Like the most common one, you have to be y equals. Number 2, again, let's say we did substitution on this one. I could solve the bottom for x. And then take this and 5 times 5 minus 3y plus 2y equals negative 1. This becomes 25 minus 15y plus 2y equals negative 1. Negative 13y would equal negative 26. Y would equal 2. And then I'm going to take and plug that back in. And I get negative 1 too. So let's say I had graphed this, because you're going to have to do it when it asks you to. For these, I would have had to solve for y. So I would have taken this and I would have said 2y equals negative 5x minus 1 and divide by 2. And I would have gotten y equals negative 5 halves x minus 1 half for that one. And then this one, 3y would equal negative x plus 5, and y would equal negative 1/3 plus 5/3. So that first one, I would have started at negative 1/2, and I would have gone down 1, 2, 3, 4, 5 over 2. And I would have drawn the line. And then the second one, I would have started at, this is 1 2/3. And gone down 1, 2, 3, no, sorry, 1 over 3. And up 1, left 3 is also the same thing. Oops. So this is hard to see because those lines aren't straight. But right here, where it appears to cross, okay, I could always double check that by plugging that point in and making sure it works for both. But that would have been my solution. Remember that the special cases are if they cancel out, variables cancel out for substitution, and what's left is a false statement, what's your answer? No solution. And if it's a true statement, like 1 equals 1 or 0 equals 0, can we equal 0, then what's your answer? All solutions. Okay, all real numbers. And then the same thing for the graphs. If they don't intersect, then it's no solution. If they do, then it's all real numbers. All right, then you had a couple of word problems. You had 3 on Friday's notes. And it says you're given the yearly interest from a total of $25,000 invested in 2 funds paying the given rates of simple interest. Write and solve the system of equation and then find the amount invested at each rate. So here's my interest. Here's my total amount invested. This is my rate at 2%. And here's the rate at 4%. So I know the total amount invested, x plus y, equals 25,000. And I know that 0.02x plus 0.04y equals 730. So then I would do two things. One is get rid of these decimals. So this would be 2x plus 4y equals this house. So it has to get the 2 zeros. So 73,000. And then I would solve one of these variables for the top. And it doesn't matter which one. If in the top it had said find the amount invested at like 2%, then I would want to make sure to save the x. But if it just says both, it doesn't matter. So I can say that x equals 25,000 minus y. And then I'm going to take that and plug it in there. Y. And then divide by 2. So that's your y, and then subtract that from x, or subtract that from 25,000 to get the x. Wait, I have too many zeros here. So it's 13,500 at 2% and 11,500 at 4%. So these are also easy to check. Obviously, they should add up to 2,500 or 25,000, but we just subtracted from 25,000, so that should be fine. But with a scientific calculator, I can quickly say 13,500 times 0.02 and 11,500 times 0.04. Add them together and make sure that it's equal to that $730. So these are easier to check. All right, so this one said solve the system using substitution and then check your answers graphically. So if I wanted to solve for these, I certainly would avoid the squareds, because then you have to do plus or minus. So if I took this one and said that y equals negative 5/3 plus 1/3 x, and then I could take that and I could plug it into the y here. So x squared plus y squared, which would be negative 5/3 plus 1/3 x squared equals 25. So then I've got to distribute or expand and distribute that. So this is 25/9 minus 15, or sorry, minus 5/9 minus 5/9 x plus 1/9 x squared. That's all in the parentheses. Combine your like terms. Okay, and then if I don't need the parentheses because it's just addition. If I wanted to get rid of those, I could just multiply by 9. So 9x squared plus 25 minus 10x plus x squared equals 225. Then combine my like terms here. And I'm going to have to move this over. Take out the 10. And then factors. -5, +4. And this will never be 0, but I get 5 and I get -4. Then I take those and plug them back in. So it doesn't matter where you plug them back into. If you want to plug them back into here so there's a fraction, you can. If you want to avoid that, you can square them. It doesn't matter. It goes there. So I would do 5 squared plus y squared equals 25. 25 plus y squared equals 25. Y equals 0, or y squared equals 0, which is y equals 0. That's the first one. And then -4 squared plus 25. And that's 16. And that's 9, which is plus or minus 3. And then when you verify it, you see that it's only happening here and here, which is the 2 points where it cross. So it gave it to you to verify. All right, this is the second one that you would ask for. Solve the system of substitution and then check your answers. So I would have taken the top and I would have solved like x equals 0 minus y is just negative y. And then I would have taken that and I would have plugged it in the place of the y. Wait. Yeah. So I would have gotten, I would have probably done the other way, but let's just go with it this way. X equals, this is negative y to the third minus negative y minus y equals 0. This is negative y to the third plus 5y. This is minus. So those are your three y's. 2, 0, and negative 2. And then just take them and plug them back in, and I'd plug them back in up here. X equals 0 is just 0. X equals negative 2, that becomes positive 2. And x equals negative positive 2, and that becomes positive 2. And that's where these come from. And then when you check your graphs, right, there's match, match, match. Okay. Use the graphing utility to solve the systems of equations. So you just have to plug them in. So the first thing I would do is solve for y. So y would equal ln of x minus 1 minus 2. And then this one, I would have to do 9y equals 9 minus 2x and divide by 9. So this is an example of something like you would see on your test where you could not solve that any other way. You'd have to plug it into your graphing calculator and then find where they cross. So I typed that one in. So once I got them solved for y, I have to finish typing it in, but so this one you'd group your numerator, 9 minus 2x divided by 9, and then graph it. And then remember to catch the intersection. I'm going to go second trace. Number 5 is intersect. I'm going to highlight somewhere along this one. Ask the blue curve is the first one. Where's my little? There it is. And then the second curve, the red. And then hit enter, and it will bring you to the intersection. So it says 6.136, which gets rounded, and then negative 0.36, which gets rounded. So that would be an example, like maybe a test question, something that you'd have to graph with a graphing utility. This wouldn't be on your quiz because you don't have the graphing utility. Yeah, that was your question.
Can you give me just like, is it like sometimes there's like cubes or whatever we can have as a test graph?
Sure.
How would, you said it's different, we don't have to find the intersection of 3 lines.
Oh, no, not 3 lines, but a cubic line, sure.
No, but like, I mean, are we gonna have to like graph and all that?
With 3 lines?
Yeah.
No.
Okay.
No, they're still systems. Yeah. You get systems of variable 3 equations. That's like a 3D line. I won't show that to you. Okay, this is number 8 from the homework. It says solve the system graphically. So I've got x squared plus y equals 4 at the top. I'm going to change this so that it's in standard form for a parabola, which is going to be y equals negative x squared plus 4. And then the bottom, I'm going to solve this as a line. So it's negative 3y equals negative 9x minus 12. And then divide everything by negative 3. And I get y equals 3x plus 4. So that line would be at positive 4, up 3 over 1, down 3 over 1. And then I'm going to draw my line. So that it's sort of straight. And then I'm going to go back and do my parabola. So the parabola here we know is plus 4, so it's going to be up here, and then it's going to point downward because of that negative. So remember, you can use your transformations to get you a roundabout, but I need to find those exact points. It looks like it's going to hit at this point here, but really my parabola is like a down 1 and over 1, so it's going to do that. And then I would keep going till I found the next one. All right, so we don't know exactly what's going to happen there, so I'm going to plug in -2 to see what's happening here. So y would equal -2 squared plus 4, and this would be -4 plus 4, which is 0. So that actually, the parabola would hit that point right there. That's not on my line, so I'm going to try again. Let's try -3. Y equals -3 squared plus 4, -9 plus 4, which is -5. So -3, -5 is a point on my parabola. Let's see if it's a point on our line. So the last point I drew, I went from +4 down, up 3 to the right one, or down 3, 1, 2, 3 to the left one. I'm going to go down again, 1, 2, 3 to the left one, down 1, 2, 3 to the left one. And that's a coordinate point that matches -3, -5. So we've got the 0, 4 that came from the overlap of the vertex and the coordinate point -3, -5. So this one, if I solve, let's say I solve for x, actually I'd solve for y so I don't have to square it. I'd get 7 minus x, take that, plug it in. X squared plus 7 minus x equals 6. Subtract this, and I'd get +1. So when you go to solve this, this is not factorable. If I do the quadratic equation, I'd get plus and minus. A is 1, b is -1, c is 1. So -b plus and minus square root of b squared minus 4ac all over 2a. And what happens here is I get the square root of a negative number. Which can't be done. So that's why it's no solution that way. If you had graphed this, this would have been a parabola. Y equals -x squared plus 6. And a line, y equals -x plus 7. A line that looks like that. And a parabola that looks like that, which they would never intersect. So either way, you gotta, like if you solve it algebraically, you end up with a square root of a negative number, which can't happen. And if you graphed it, they wouldn't overlap. This one, your numbers might be different, but it said you're offered 2 jobs selling college textbooks. One company offers an annual salary of $30,000 plus a year-end bonus of 1% of your sales. The other company offers an annual salary of $22,000 plus a year-end bonus of 2% of your sales. What's the minimum you'd have to sell in a year to make the second offer better? So the sales is the question mark, right? So this is like saying your sales. That's what we don't know, okay? But it's going to be the same for both ones. So this is 2 equations, but it's actually still just one variable, okay? If your salary is $30,000 plus 0.01 of your sales for the first company, that's the first one. And then for the second one, it's $22,000 plus 0.02 of your sales. So this would both equal your income. So that's where it kind of has a system because it's 2 variables, okay? But the question is, what's the minimum you would have to sell in order to make the second offer better? So if it's better, then it's going to be greater than, right? So I actually want to see...
Are those I's actually equal?
I just said it's income. You can make it anything you want. You don't even need it because you're saying they're both the same. So I want the right side to be better than the left side, which means I want the right side to be greater than the left side. So then I would subtract, well, actually, maybe I'll get rid of the add on a 0. Oh, 2 zeros. Because you'd have to move that twice. You have to move that twice. So I add on 1, 2, 3, 4. Yeah, okay. Then subtract. Subtract the x. Oop. So x has to be greater than 800,000 to make that offer better. It's a great standardized test question. So 7-2 is systems of linear equations and 2 variables. Okay, we are now doing elimination. So after today, you will know 3 ways to solve systems of equation: graphing, substitution, and elimination. And again, if the directions say specifically to do a specific one, you need to do that. But if it just says to solve, you've got options. You can choose between them, and you get to pick whichever one makes the most sense. My advice is be comfortable with all 3, because sometimes one is, like, sometimes it's already set up for substitution. It's going to be easier to do that. Sometimes it's already set up for elimination. It's going to be easier to do that. So just make sure you know them well enough that you can bounce and forth. All right, so if we're solving using elimination, you're going to get both equations in a standard form, which means the x's and the y's have to be able to line up. And then the constant is on the side by itself. If you need to, you're going to change one or both of the equations so that when combined, one variable will cancel out. Okay, once you look at the 2 equations, you're going to see if you can cancel out variables by adding the 2 equations. If you can cancel them outright, then you don't have to change anything. If you can't cancel them, you're going to change one or both equations so that they will cancel out. When you add these 2 equations or combine them, one of the variables should cancel out, and then you will solve for that remaining one and plug it back in like we do with substitution. There are the same 2 special cases in elimination as there are substitution. If your variables cancel out and you're left with a false statement, then it's no solution. If the variables cancel out and it's a true statement, like 1 equals 1 or 0 equals 0, then it's all real numbers. All right, first example, we're going to take some baby steps, okay? 2x plus 3y equals 13, x minus y equals 9. So if I add these as they are, will they cancel out? No, what can I do? Good. So typically I would go with ones that already have an opposite sign and one that can go into the other one. So I'm going to carry this over. 2x plus 3y equals 13. 3x minus 3y equals 27, and then add 5x. These cancel. Equals 40. Divide by 5. And x is 8. So there's the first coordinate. And then I can take and plug them back into any of the originals or the one I multiplied to change. It doesn't matter. But I would go simplest. So I would stick to the x minus y equals 9. So 8 minus y equals 9. Negative y equals 1. And y equals negative 1. And again, with extra time, I can take that. I can plug it back in to check it. All right, A, I get y minus x equals 10 and y plus x equals 20. Is this already set up to cancel out? Yeah, super easy, just add them. I get 2y, these cancel, equals 30, and then divide by 2. Y equals 15. Take it and plug it back in, and it doesn't matter which one you plug it back into. So if I plug it back into the bottom, I get 15 plus x equals 20, and x equals 5. And again, super easy to check these. You just need a little bit of extra time. Plug them back in. Okay, how about B? Set up to cancel if I add these. No, right? Can I change just one of them? No, so there's no multiple of 2 that's going to go into 3, and there's no multiple, 3 or 2 that are going to cancel out, or 2 or 5. So what's one way? It's not the only way, but it's one way that you could do it. Sure, greatest common factor, yeah. So what would least common multiple would be it, but it's fine. I know what you're saying. If I wanted to cancel the x's, what would I have to do? Top by 2, bottom by negative 3, right? So one's going to be positive, one's going to be negative. If I go with the y's, I do what? Top by 5, bottom by 2. My advice to you, for as many stupid mistakes as you make with signs, try to avoid changing the signs. So I would go to the ones that are already positive and negative, as long as they're not super yucky numbers, right? So then I would say this is 5 and this is 2, and I get 15x plus 10y equals 20, and I get 4x minus 10y equals negative 58. So again, for as many silly mistakes as you make with signs, I would say avoid it if you can. This is 19x cancels equals negative 38. Divide both sides by 19, and x is negative 2. Take and plug it back in, and you can plug it back in anywhere. So if I plug it back in here or here, God bless you, it doesn't matter. So 3 times negative 2 plus 2y equals 4. Negative 6 plus 2y equals 4. 2y equals 10, and y equals 5. So obviously you're going to see fractions, you want to get rid of them. You're going to see decimals, you're going to want to get rid of them. All that stuff that you can see in substitution, you'll see come back in this stuff, okay? So notice the change in directions this time. It says use any method to solve. So this is where you get your choice, right? So go ahead, solve. I would say pick between substitution, elimination. You could use graphing if you want, but you don't need to. So if it was set up the way it was on the left, I would say probably use elimination. That's 7, because it already cancels. 7x equals 42 and x equals 6. Take it, plug it back in. 6 minus 5y equals 21. Negative 5y equals 15. Divide by negative 5. And y is negative 3. If it was set up like this, because that's the same thing, then I would say that this is easier to use substitution. So if it already gives you what one of the variables is equal to like this, then I would say that I would want to use substitution and plug it in. So again, just keep in mind, you can move it and do elimination, but sometimes it's easier to use one over the other. Questions on that one? Okay, then we get to word problems, sort of word problems. There's more words in this than solve, but this is not a huge word problem. It says find the equilibrium point of the demand and the supply equations. This is just like break even, okay? Equilibrium is what's the optimal amount of units to sell and at what price. So there's two parts to it. Again, this is like when a business wants to figure out how many do I want to produce so that I don't lose money, or I don't have a bunch of inventory sitting on shelves I can't sell. So you want the perfect match, which is when demand equals supply. Notice they are both equal to P, right? So I could take the time and line these up. And then I could get both variables to one side so that I can solve it with elimination. It'd be 0.4x plus P equals 500. And negative 0.1x plus P equals 380. And I could go from there, or if they are both equal to P, what's true? I can just substitute this in. So I can say 380 plus 0.1x equals 500 minus 0.4x. Now this, be careful on, because this is where people make mistakes. Let's say this number was like a 0.01x. They multiply the right one by 100 and the left one by 10. You can't do that. You're saying they both equal P, so you have to get them equal to each other first and then change the entire equation. So this one, if I wanted to get rid of the decimals, I could just multiply everything by 10. You have to remember to go across the equal signs. That's the other mistake people make. Now I can add the 4x. Solve for x. So x is your number of units. So the ideal amount is 240 units. It needs units and it needs price per unit. So what do I do with that 240? Take it, plug it back in, and it doesn't matter which one you plug it into. Multiplying by a 0.1 is a little bit easier than a 0.4. So I can do 380 plus 0.1 times 240. That's moving my decimal one place. And that's P. So that is your ideal amount. 240 units at $404 per unit. This is not like break even where you have to round up. So if it says to round this, you round to the nearest whole number, okay? This is not like break even. You're not trying to find like where you would be making money. You're just trying to find the best combination. Questions on that one? All right, then this says a minor league baseball team had a total attendance one evening of 1,175. The tickets for adults and children sold for $5 and $3.50 respectively. The ticket revenue that night was $5,087.50. Create a system of linear equations to find the number of adult and children tickets at the game, and then solve your system using elimination or substitution and use a graphing utility to verify. All right, so let's pick out from all those words what's the important part, okay? First of all, what are my variables?
X and Y.
You can do X and Y. X could represent what?
Children.
Sure. So it doesn't matter as long as you know what you're doing, right? So you can even make it A and C to make it better. A could be your adult. C would make it children, except that we're going to eventually graph this, so you can also say this is X. And this is Y. You could do either one. You're making your own equation, so you solve it however you want. So what do I know about the total amount of tickets sold, or the total attendance?
It was 5,000.
1,000. Well, the tickets sold, number of tickets sold is 1,175, right? So X plus Y equals 1,175. That's the amount of tickets. Now I got to give them their value. So for each value of X, how much money did we charge? If X is adult. $5 respectively means in that order, right? So 5 goes to the adults and 3.5 goes to the kids. And then how much money came in from those ticket sales? 5,087.5. You with me so far? Okay, so now I want to solve this system, okay? You can take that top, you can solve it for one of your variables, plug it in using substitution, or you could take the bottom and let's take that same system and do elimination. So if I wanted to eliminate a variable, what would you do? What's the easiest thing to do?
Multiply the top by -5.
Good. I would probably multiply the top by -5. And then I'm going to combine these together. So my x's are going to cancel. This would be 1.5y equals, put this over this. Do that right, let's see. And they're both, no wait, I did that wrong. Just kidding. They're both negative, right? Because this is negative and this was negative. Okay, and I get 1.5y equals negative 787.5. I could have eliminated the decimal from up here, okay? But then I'd have to multiply by 50. It's totally fine. It's still the same answer, okay? But what I would say is you have a scientific calculator on this. Use it to your advantage. If you didn't have a scientific calculator, you could divide that number. It wouldn't be fun, but you could do it. If you forget your scientific calculator, you would have to divide that number. It won't be fun, but you'll have to do it, okay? But with your scientific calculator, if I just did this 787.5 divided by 1.5, because they're both negative, I get y equals 525. So that's, what did y represent? Number of adult tickets. So we sold 525 adult tickets. And then how do I find y? I mean x, sorry, the children tickets. Subtract it from here, right? X plus 525 equals 1,175. Subtract out 525. Because we said X was our, oh, sorry, that's not, we said Y was our adult. I did that on purpose so that you could realize how important it is to make sure it matches up. Our Y was our children. So it's 525 children's tickets, and it's 650 adult tickets. You with me so far? Okay, then it said use a graphing utility to verify your solution. So for these, you have to solve them for y. So I'm going to take this top equation over here. I'm going to say y would equal 1175 minus x. The order there doesn't matter because you're going to type it in. And then I'm going to take this one. I'm going to say 3.5y equals 5,087.5 minus 5x. And then divide everything by 3.5. So my graphing utility, I'm going to group together my numerator. And then divide it by the denominator. Good morning. All right, so I'm going to adjust my window back to what it normally is because this is from the last one. What's wrong? I still don't have my graph, right? Where are these going to intersect? Like 520 and 650. Is that on my normal window? No. So if it's just saying to check these are way easier to do on your graphing app because you could just pinch and zoom. Does that make sense? But if you're doing this on the test, pay attention to where it should be crossing. That means I have to zoom out a whole lot, right? So I can just zoom out for now. And it's going to ask you, do you want to zoom out? And I'm going to have to keep zooming out because this is so big. But if I had on my graphing utility on my app, I would just zoom out, okay? You're going to be able to do this if this is your homework with either one. So I would use that to your advantage, okay? But pay attention. Don't freak out if you don't see a cross because this shouldn't even be close to it because our window was negative 10 to 10. So we're going to keep zooming out. I don't even know how many times I have to zoom out. But we're going to keep zooming out to see if we can catch where it's going to intersect. We got the little piece of it there, so I'm getting closer. And now I've caught my graph, okay? And then remember the intersection comes from second calc. Intersect, I don't even know if it's going to get close enough. We'll try it. We want the one curve, the other curve, and it's going to guess, and there it is. It brings us directly to 650, 525. So on your handheld, you're going to have to zoom out or adjust your window, okay, to make sure it's there. On your graphing calculator app, if you just pinch and zoom, it'll get out there.